What is the principle of superposition, and how can you use it to make circuit analysis a little bit easier for yourself? Find out right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, at your service.
Alright, problem statement. Chapter 4, problem 6, and the problem statement is to use the superposition principle to calculate the voltage across R3, which I've named as V delta. And we're going to write V delta as that's being equal to VB minus V sub D, which is VD is this voltage, the voltage at this node right here. VB is the voltage at this node. Of course, so it's the voltage across these two nodes right here. I'm writing in green, but apparently green isn't popping up right away. Now, what we have, of course, is two power supplies, V1 and V2, and you'll notice that the V2 is upside down in the circuit. It's having the minus on top and the plus on bottom. And I've chosen an arbitrary ground right here. You can put a ground anywhere you like. I've chosen one here. You have to put a ground in order to operate LT spice or any kind of spice circuit. So you could put ground over here if you wanted to, but we're not going to, so I'm going to scratch that out. But you could put a ground anywhere you like. This, although normally takes a shape like this in your textbook, in SPICE it's a round thing. Of course, but you recognize this as a voltage controlled current source. And what it says is that the current through this device is going to be based on the voltage. And as you can see, the voltage nodes, the sensors go to VB, and the other positive sensor goes to VB, and the other negative sensor goes to VD. So that is going to be our V delta right there, which determines what the current through that power supply is. So this power supply G1 is a current source, and this 1.5 here is the multiplier. So whatever multiplier, if this is 3 volts, it's times 1.5 is going to be 4.5 amps. So whatever's coming through here, or across, whatever's dropped across here, dictates the current through this source. Alright, now we have 4 essential nodes: VA, VB, VC, and VD. We have another node here, VE, but it's not an essential node. It's a node, but not an essential node. Of course, ground is arbitrary, and we selected that. And I'm reading through my notes here. It's not needed, but your SPICE programs won't run without it. So you can do the calculation without having a ground, and you can call this a reference. But all of your calculations are going to be based on relative voltages. So the ground is nice to have, but it doesn't tell us what we're going to do. So for the next, let's go on to the next slide. So the way that you do superposition, if you want to find out what the voltages are at these nodes here, you can go through all kinds of little calculations, and it's going to be some pretty nasty calculations, or you can do what's called superposition. So in superposition, we'll take out one of the power supplies and we'll replace it either with a short circuit or an open circuit. If you're a voltage source, you replace it with a short circuit. If it's a current source, you replace it with an open circuit. So we're going to take out one of these voltage sources, and we're going to place it, and we'll go, here's the next one, and we're going to replace it. As you can see, we've taken out V1. So what we've done is we've taken out V1 and we've replaced it with a closed circuit. Now, in order to do this calculation, at this point we want to figure out what VB and VD are. So we're going to calculate these. We're going to write some formulas for these. And looks like I need 3 formulas. and I'm going to write those. I'm going to write those out now. So the first node we're going to look at is going to be, it looks like let's see, it looks like we're going to look at VA. Okay, so we're going to look at VA, and we're going to look at all the currents going away from VA. Alright, so what this comes out to is going to be, let's see, alright, the first one, this is 1.5 V delta, right, so that's this current right here. So let's write that 1.5 V delta plus, and the next one is going to be VB, let's see, VA minus VB, and VA minus VD. Okay, so it's going to be plus VA minus VB over R1 plus VA minus VD. And you notice I'm just skipping right past VE because it doesn't really do, there's nothing there. VE and VA are the same in this one. Over R4. Alright, so that's our first equation, and that's equal to 0. Pin's not really doing all that. The next one we're going to do is VB, the currents away from VB. Alright, so we're not going to do this current because this is just a sensor, so we're going to ignore that. We assume that on a sensor there's no current going through it. Really we want to look at this current, and this current. So we're going to ignore, when we do the calculations, we're going to ignore these sensor lines, which is basically SPICE nodes for this power supply for G1. So for VB, we have VB minus VA over 6 plus VB minus VC. I'm going to put this, I'm going to change this to R1. And you can put numbers or letters if you want. If you put numbers, it'll make it a lot easier to do the calculation because you can just multiply the numbers, especially if you don't have a Mathcad. What I'm going to use is I'm going to write in the formulas over R2, and you can put numbers in as you like, plus VB minus, let's see, did I use that? VD over R3. And those are all equal to 0. And then, of course, the last one I'm going to do, let's see, which one did I do? You can do, the last one I did was VC. So I did this one. You can do VD or VC, but we want to get all of the devices in here, and so far we don't have anything on V2. So, and that's fine. Now this last one is going to be a little peculiar. No, not really. Okay, so on this one it's going to be minus 1.5 V delta, and of course this is what V delta is. 1.5 V delta is the current going this way, but we're looking at current going away from the node, so that's going to have to become a negative value. Minus 1.5 V delta plus VC minus VB divided by R2 plus, now we're going to have 0. Alright, so I'm going to look at the, okay, so how do we get this one here? How do we get the current here? We've got a voltage in the way. It's not going to be VC. We've got a reference, and that's going to make things a little bit easier right here. We're going to call that 0 minus V sub D divided by R5. Now you're wondering why I picked this point right here, maybe. But what's happening is that I've got a current going this direction. And whatever current that is, it doesn't matter. It's going to be the same as this current right here because there's nothing in between. There's nowhere else for this to go. This is a ground. This is 0. And that's all equal to 0.
Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.